to do a half parabola projectile problem. We have a raw egg thrown horizontally straight out of the open window of a fraternity house. If its initial speed is 20 meters per second and it hits the ground 2 seconds later, at what height was it launched? So if we drew a picture, this is what it would look like. Essentially, you have a perfectly horizontal velocity. Let's draw it with vector arrows. A perfectly horizontal velocity. Okay, and this object, it's an egg in this case, is going to go out the window perfectly horizontally and fall to the ground in a pattern that looks somewhat like a half parabola. And it's going to land on the ground, right? So what we're trying to find is what is the height that it was launched from. So we've got a number of things. So I will label the x direction objects in green, my initial velocity in the x direction, that's equal to 20 meters per second. The range or displacement in the x direction, I don't know what that is. And I do know that the final velocity in the x direction is equal to 20 meters per second because the acceleration in the x direction is 0. Now I'm labeling all these things. Maybe I need it, maybe I don't. So in purple I'm going to label all of our y components. So my initial velocity in the y direction, well, that's 0. And the reason it's 0 is because this thing's launched perfectly horizontally. There is no initial velocity in the y direction. It's almost like dropping the egg. Okay, so it's similar to dropping the egg. So I will move this up here because I also want to put in that the displacement in the y direction, we don't know. We don't know the displacement in the y direction. And in fact, that's the question. What height was it launched from? So if we can figure out the displacement, we can figure out the height that it's launched from. Now, I don't know what the final velocity is in the y direction. Maybe I need it, maybe I don't. I know my acceleration in the y direction. That's equal to negative 9.81 meters per second squared. And that's assuming that down is negative and up is positive. Okay? And the last thing I know is time, which for half parabola problems, the time is the same for x and y, and they tell me that this thing falls to the ground in a time of 2.0 seconds. 2.0 seconds is how long it takes to hit the ground. 2.0 seconds. So if I want to find the height that it's launched from, this is as simple as saying, okay, well, this is just the same as a dropping problem, where we just take all of our y component information. In the y direction, what do we have? We have an initial velocity in the y direction. That's 0. We have an acceleration in the y direction. That's negative 9.81 meters per second squared. The final in the y direction, we don't know. Maybe we don't need to know. We have the We are looking for the displacement in the y direction. That's also a question. And we have the time equal to 2. So we can use what we define as our third equation. Displacement in the y direction is equal to initial velocity in the y direction times time plus 1 half acceleration in the y direction times time squared. Plug in all your information for this. This all becomes 0 because the initial velocity is 0. So that's 0 plus 1 half times negative 9.81. And I'll leave out the units just for simplicity. And this is 2 squared. So that's going to tell me my displacement in the y direction. I should get a negative answer because it is displacing negatively according to my direction. So we've negative 1 half times negative 9.81 times 2 squared, and that is equal to negative 19.6 meters. So the height above is 19.6 meters. So our height is 19.6 meters because we know our displacement is negative 19.6. That's the answer for problem 108 in the textbook.